Hey everyone, let's look at number 20 in section 4.3. We want to find the critical point and determine if the function is increasing or decreasing on the given intervals. I want you to use decimal notation in giving your critical point, rounding to 3 decimal places. So here's our function, and notice that they have a restriction for all values only greater than 0. The domain of this function is all values of x greater than or equal to 0, because the x to the 5/2, right, is either the square root of x to the 5th or the square root of x raised to the 5th power. Either way, you're taking an even root, and therefore the radicand, the stuff you're taking the root of, needs to be non-negative. Okay, but they're restricting it to only positive values. Okay, so with that, when we find our critical point, we are going to take the derivative, and so the derivative of 5/2 is by the power rule, 5/2 x, right? Subtracting 1 from 5/2 gives me 3/2, and then bringing the 2 down here gives me negative 16x to the first, just using the power rule on those. Now, to find out when this derivative is 0, it's never undefined. I'm going to factor it, right? I'm going to factor out a common factor of x, what, to the first power. And when I pull it out of this first term, I'll be left with an x to the 1/2, 5/2 times x to the 1/2. And of course, here I'll just be left with 16. Of course, then this thing will be 0 when x is 0. But again, remember, we're restricting to values greater than 0. So 0 will not be the critical point we're looking for. Basically looking for a positive critical point. So looking at this part in the parentheses, that's going to be equal to 0 when what? Well, if I add 16 to both sides and then multiply by 2/5, right? If I multiply both sides by 2/5, that will give me a coefficient of 1 here. And then 16 times 2/5, 16 times 2 is 32/5. Remember, x to the 1/2, again, is just the square root of x. So to find x, I need to square both sides. So squaring the square root of x gives me x, and this will be 32/5 squared, which is this, right? If we use our calculator to compute that. There, it's better. So, and this says to round to 3 decimal places. So again, your numbers might be slightly different here. In my case, right, I technically don't have to round, it's 40.96, but they want you to, I think, add in the 0 just to, I don't know if they give you an error because of 2 decimal places, but I would include the 0 just to be sure. But of course, if your number has more decimal places, make sure you use the correct rounding rules. So the first, they say critical point C. So what are they talking about C? This is there's one critical point, and that's what goes in the blank, the one we found, all right? So 40.96 is the value of C in this problem. And then in order to answer the next 2 questions, we do need to do a sign check on our derivative up here. So remember, it's only positive values of x here. 40.96 is our critical point, and the derivative is 0 there. And then we just plug in a value less than 40.96. I plugged in 1 and got negative 13.5. You can do this quickly if you want to just use your calculator as well. There's my derivative. Notice 5/2 is 2.5. X to the 3/2, which is 1.5 minus 16x. And then just go to the table of values. I plugged in 1. So we said here I get negative 13.5. And then something bigger than 40.96 is like 41. And I get positive 0.3202. So it's always positive on that interval. Okay. So once we have that, we can now answer the questions. They say on the interval from 0 to C, everything between 0 and C, where C is 40.96, what's going on? Well, since the derivative is negative, we know our function is decreasing. From 40.96, right, C to infinity, then what? The derivative is positive, so our function is increasing. That's what they want. Now, they don't ask for this, but we can also use the first derivative test to determine what? Do we have a local minimum or a local maximum at 40.96 at our critical point? Well, since the derivative changes from negative to positive, we have a local minimum. And it should make sense because we're saying initially from 0 to C, we're decreasing, and then from C on, we're increasing. So we're going down and then down to 40.96 and then continuing up. That's going to be a minimum. There is no local maximum for this function. Okay, I hope this is helpful.